In this presentation, we are going to see how to solve problems using K-maps. Before that, we should be knowing why we should go for K-maps, because all the time we'll be asked to simplify Boolean expressions, or in the sense logical expressions, right? So what do we follow? We follow Boolean algebra to simplify Boolean expressions, right? So remembering all the Boolean laws and rules when simplifying Boolean expressions is actually practically difficult. So that is why we are going for another technique, simplification technique called K-maps or Karnaugh maps. So there are 5 points to remember when you are simplifying a Boolean expression using K-maps. And the first point is the size of the K-map is given by the formula 2 power n, where n stands for the number of variables given in the logical expression, right? It may be 2, maybe 3, 4, 5 or 6, right? The limitations of K-map is up to 6, right? The n stands for the number of variables. And third point is fill in the K-map with ones according to the given logical expression or Boolean expression that we are going to see. And we have to do the grouping, right? So form the groups as bigger as possible when you are solving the K-maps. So we'll see a problem. So we'll go with the two variable K-map simplification, right? So we'll be given with the problem f of a comma b. So that is equal to summation minterms 0 comma 2, right? So this is the given problem given to you, right? So according to this problem, you have two variables. So what are the two variables? A, b. So n equal to 2, right? The size of the K-map, size is equal to 2 power 2 or 2 power n, right? So that is equal to 2 power 2, that is equal to 4. 4 in the sense 4 cells will be there, right? So how to draw the K-map? Can draw like this. Draw a square and divide the square into 4 equal cells, and there you go. And you can put a split here, right? The split shows the A most significant bit and B the least significant bit. Now we have two variables A and B, right? So the possible combinations of zeros and ones for A and B is nothing but A can be 0, B can be 0, A can be 0, B can be 1, A can be 1 and B can be 0, and A can be 1, B can be 1, right? A can be 0, B can be 0, 0, 1, 0, 1, right? Now how to fill the substance which is there inside the map? So 0, 0 is nothing but m naught. Where is 0, 0 combination here? Put m naught, right? M naught, m stands for the minterms when given in the question. 0, 1 combination gives you minterm 1, 0, 1. So 1, 0 combination gives you minterm m2. The third minterm, last one is 1, 1 combination of A and B gives you m3. So that is how this K-map is filled with minterms, right? So according to your problem statement shows you that you have two variables, two values 0 and 2, right? So where you can see 0, you can see 0 here, right? 0, 0 combination of m naught, you can see 0, right? 0, that you can see from the truth table, right? And next one is 2. Where is 2? 1, 0 combination gives you 2, which is the place for m2, 1, 0, right? So you can put a 1 here. The rest of the other two cells, they don't have anything mentioned in the question, so simply ignore those two, m1 and m3. Simply place them empty. Okay, don't worry about these two other two cells. Now we have to do the grouping according to the rules which we saw earlier, right? Form groups, group the adjacent cells that are already filled with the ones. Now let's do the grouping now. So we have to do the grouping like this, right? m0 and m2 are grouped together because they are adjacent to each other. So that is why we have grouped them, and this is how you group them. The group travels in this way from the top to bottom. That means from m0 to m2, right? So since it is traveling from the top to bottom, can write the question now. F of a comma b is the question given to you. Since it's traveling from the top to bottom, b's value is not changing. It is common from m0 and m2. Since b is 0, right, we can put it b bar, right? So B is 0. It is common for M0 and M1. But you can see A is changing from 0 to 1. Since A's value is changing from 0 to 1, we cannot take the value of A since the bit value of A is changing. So the only one possible combination available here for this is B bar. So the answer is B bar. If you solve this question, it will be giving you B bar according to K-map. Right? So the thing you should remember is the size of the K-map, the number of variables. According to that, you have to follow the grouping, right? And M0, M1, M2, M3, you have to place. Once you place M0, M1, M2, M3 on the places, then you can plot the maps, then you can draw the grouping, right? Can you group for 0, 1, 3? If you group for 0 and 3, so it can be like this. It is a diagonal, which we will see later in the forthcoming videos, right? So this is a very different operation that we'll be explaining. And the next video will be dealing with 3 variable K-maps. 3 variable K-maps coming up the next video. So if you have any doubts, you can put it in the comment section if you require any more videos on K-maps. And thanks for watching, and please leave a comment if you have any doubts or if you have anything to share with us.